Hi, good day to you, and welcome to my channel where I tutor you in science for free. The topic in this video will be energy changes. This topic talks about the changes in the energy level within the molecules of the reactants versus that of the products. It is not required of this level to understand the exact number in terms of bond energy between different atoms. Like shown in this table, you do not have to understand them, but do know that in every bond, there carries some level of energy to hold them together and to break them apart. And different atoms hold on to each other with different strengths. Therefore, breaking them or joining them together will cause the reactant or products to have different levels of energy. So because energy cannot be created or destroyed, it merely transfers itself from one version to another. And the two changes that you will need to understand from this topic will be the exothermic reactions and the endothermic reactions. So what do they mean? Exo means exit, thermic means heat. So in the exothermic reactions, heat is released, heat exits from the molecule. You will feel that the container gets warmer. On the other hand, endothermic, endo means enter, thermic means heat. So heat enters, which means to say that energy is absorbed. The container will feel colder because heat is conducted away from your hand and enters the reaction system. Temperature time graph will look something like that for exothermic changes. This is pretty much common sense. You'll gain in temperature. After a while, you will go back to the resting temperature. These are a list of reactions and processes that releases heat energy. So of course, condensation to have the molecules come from a gaseous state to a liquid state. It has to lose energy. So where it loses to the environment. It gives out energy. That's why it's exothermic. Similarly, for freezing, neutralization is a popular example for exothermic change. It's commonly asked in questions. Combustion of fuels as well. Everything that requires the addition of an O2. So recall that neutralization is the reaction between a base and an acid. And exothermic change also has an energy graph that looks like this. The first level will be the energy level of the reactants. It has to first overcome the activation energy, which is this height. And because it's exothermic, it releases energy. It will end with a energy level lower than that of the reactants. And this will be the enthalpy change. This is some new vocabulary that has to be understood for this chapter. If you're talking about the reverse reaction, if you want to take the products and form back the reactants, this is called the reverse reaction. So the terminology will be reversed. The activation energy will be the long one, and then the enthalpy change will be the gain in the height. So whenever you see enthalpy change that is being negative, this means it's an exothermic change. Heat is released. That's why it's negative. And we will go on to the next one, endothermic change, which is the complete opposite. This will be the temperature graph because it loses heat energy. After that, it will go back up to the resting temperature. And these are some common examples of processes and reactions that takes place. So conversely, to exothermic change, melting and evaporation, you need to gain the energy to overcome intermolecular forces of attraction to change in the state. So do also note that dissolving things like this will be endothermic as well. Commonly asked, photosynthesis is one chemical reaction that is endothermic, which is very interesting because it takes in the light energy, receiving the energy from outside to the inside to form the bonds. Although the general rule of thumb of endothermic reaction will be more of bond breaking. You imagine yourself trying to break a stick. You need to apply a lot of energy into the stick to break it. Exothermic reaction mainly is about bond formation. I like to imagine myself forcing two oranges together and the juice will be squirted out. It's like bond forming and energy is released. So thermal decomposition is one example of endothermic reaction. Subjecting carbonate to heat will give you an oxide and the carbon dioxide. Do not confuse thermal decomposition with combustion because combustion happens at the Bunsen burner. Thermal composition happens inside the carbonate. So endothermic reaction will look like this for the energy graph because they gain in energy, therefore the products will have a energy level that is higher than that of the reactant. Okay, two other concepts will be if there is no activation energy talked about in the question, you can draw your energy change like that. Just 90 degrees down, arrow will do. And lastly will be about the catalysts. Catalysts are items that speeds up reactions, lowering the activation energy, makes the reaction happen quicker and faster. So the initial harm will be a bit lower, but of course the energy level of the reactant and products will remain the same. Like mentioned initially, the exothermic reaction has negative enthalpy change because the energy level goes down. Because this one goes up, the enthalpy change will be positive. And that is all for today. Hope you enjoyed this video. Do give it a like and subscribe and share it with somebody who needs to see this. And I will catch you in the next video. Bye!